Hello dear students, welcome to Toppscholars. Today we'll be discussing about substitution reaction. So friends, what do we actually mean by substitution reactions? Yes, substitution reactions are reactions wherein one type of atom or group replaces another group or atom in the substrate. In simple terms, a substitution reaction is a reaction wherein one type of atom or group is replaced by another group or atom. Let's take an example to understand this, right? Now, in this reaction, R stands for alkyl group, whereas X stands for halogen. So now on the reactant side, you can see we have R single bond H, right? R single bond H is nothing but alkane, exactly. Now alkanes react with halogens in the presence of sunlight, resulting in the formation of R single bond X. R single bond X is nothing but alkyl halide, which is also known as haloalkane. Along with this, you can see we have HX that is formed, right? What is HX? HX is simply hydrogen halide. So friends, in this reaction, you can see that the hydrogen atom that is present in the alkane is replaced by the halogen atom. That is, alkanes, when they react with halogens in the presence of sunlight, result in the formation of alkyl halides, that is haloalkanes, along with hydrogen halide. So here we can see that the hydrogen atom of alkane is replaced by the halogen atom, and so it is an example of a substitution reaction. As we said, substitution reaction are reactions wherein one type of atom or group is replaced by another group or atom. One of the best examples of substitution reaction is the halogenation reaction. Let's take an example to understand this, right? So here you can see we have an alkane, that is R single bond H, right? It reacts with the halogen molecule in the presence of sunlight, right? And let us see what are the products that we get, right? Now this halogen molecule in the presence of sunlight, it breaks down to give you two halogen radicals, right? Now one of this halogen radical combines with the alkyl group, forming R single bond X, that is the alkyl halide. Whereas the other halogen radical combines with hydrogen, resulting in the formation of hydrogen halide. So in this reaction, we saw that the hydrogen atom of alkane is replaced by the halogen atom, right? So in this reaction, alkane, that is R single bond H, on reacting with halogen in the presence of sunlight, results in the formation of haloalkane, that is R single bond X. Along with this, we get hydrogen halide, that is H single bond X. In this reaction, as hydrogen atom is replaced by halogen atom, we say that this is an example of a substitution reaction. Let's take one more example to understand this, right? So let's take an example of chlorination of methane. So during chlorination of methane, that is, we know that methane is a saturated hydrocarbon, right? That is, in methane we have carbon atom which is bonded to 4 hydrogen atoms, right? That is single bond, right? That is why we say that methane is a saturated hydrocarbon. Now during chlorination of methane, the 4 hydrogen atoms that are present in methane are replaced by chlorine atom one by one. So as you can see over here, in the first step what happens is, one hydrogen atom of methane is replaced by one chlorine atom, and so we get chloromethane. Now this chloromethane further undergoes halogenation, and what happens is one hydrogen atom is again replaced by one chlorine atom, and so what do we get is dichloromethane. Now in the third step, one hydrogen atom from this dichloromethane is replaced by one chlorine atom, resulting in the formation of chloroform. Now further, this chloroform on halogenation forms carbon tetrachloride. That is, again one more hydrogen atom is replaced by chlorine atom. So here, as we can see, one by one each of the hydrogen atom present in methane is replaced by chlorine atom. So now friends, let's quickly understand stepwise how does the chlorination of methane actually occur. So in step number 1, what happens is, one of the hydrogen atoms of methane is replaced by a chlorine atom, resulting in the formation of chloromethane along with hydrogen chloride. So here we have methane, wherein we have carbon atom which is bonded to 4 hydrogen atoms. We have chlorine molecule which contains 2 chlorine atoms. Now in the presence of sunlight, what happens is the hydrogen atom of methane molecule is replaced by 1 chlorine atom. So what we get over here is chloromethane. Whereas the hydrogen atom that is replaced combines with the chlorine radical, resulting in the formation of hydrogen chloride. So here we can see that in the first step, 1 hydrogen atom of methane is replaced by 1 chlorine atom. To learn more about this topic, download Toppscholars app.